Hello everyone, myself Devashish Das, Assistant Professor of Electronics Communication Engineering Department of Greater Kolkata College of Engineering and Management. In this video, we are going to study about the different topics of analog electronics and its applications, how the analog electronics apply in our different fields of electronics. In this video we are going to study about it, different circuits and its part we are explaining one by one in this topic. Analog Electronics 1. This course is mainly for diploma students of electronics and telecommunication engineering of third semester. The paper code is ETCE AE1S3. Hello, welcome to another session of my video lecture. In this session, we are mainly going to discuss about the amplifier, needs of amplifier, gain of the amplifier, different configuration of amplifiers, and CE amplifier, that means common emitter amplifier. So we are going to discuss this one by one. So first let us begin with the amplifier. So what is an amplifier is? So amplifier raise the level of a weak signal. No change in the wave shape, no change in the frequency of the input signal. First, coming to the first point, the amplifier raise the level of a weak signal. That means a weak signal is being amplified in terms of its voltage and power. Both of the signals may be required. For some of the cases, for power amplifier we require power, and for signal amplification we require the level of the voltage or of the signal. Second thing, no change in the wave shape. That means the wave of the signals remain same. No change in the frequency of the input signal. That means whatever the frequency of the input signal is same as the output frequency of the output signal. That means the input signal frequency and the output signal frequency are same. So first come, why we need amplifier. The signal is generated just like transducer, like microphone, thermocouple. They are very weak in nature. So for that reason we require amplifier. It must be amplified before the feeding to the loudspeaker, etc. That means whatever the signal we are collecting from a microphone or thermocouple or any other transducer which converts the physical quantity to a electrical quantity, we require some amplifier to boost the signal in our desired power or amplitude level. That is why we need amplifier. And here we can see a block diagram of an amplifier. We can see it is the input signal of the transducer, or a weak signal is being used as an input signal. A amplifier always use a DC power supply. That means the DC power supply is changed accordingly with the help of the amplifier and produce the output to the load. The input signal is very weak and that signal is being boosted with the help of this DC supply. DC supply inject power and voltage to the input signal and produce the proper voltage level output of the load. In this way amplifier works, and this is a very simple block diagram of an amplifier. So we are going into a detail. First come the gain. It is a parameter of a amplifier. That means we measure gain of an amplifier. Gain is nothing but it is the ratio of output by input. It is the ratio of output and input. So we can find out gain as V output divided by V input for a voltage amplifier. It is a voltage gain of the amplifier. AV is the voltage gain. For current gain, it is the I output by I input. For current gain, or power, for a power gain, is P output divided by P input. So in this example, we see a voltage gain of an amplifier, which is the V output divided by V input. We take an example of this gain. We take V output as a 30 volt and V input as a 2 volt. So in this way we can find the gain of this amplifier is 15. The gain of the amplifier is unitless because it is the ratio of same quantity. That is why the gain of the amplifier is unitless. So in this way we can find the gain of the amplifier. It is the, or we can rather say, it is the voltage gain of the amplifier. So first we discuss the different configuration of transistor. Transistor can be connected as three major configuration: the common base configuration, the common emitter configuration, and common collector configuration. So in how many region a transistor can be operated? There are three region of a transistor is being operated. First is cutoff region, second is active region, third is saturation region. There are three region for a transistor is being operated. In these three region, any of these three region is transistor being operated. Cutoff region, the emitter junction and the collector junction are reverse bias. For an active region, the emitter junction is forward bias and the collector junction is reverse bias. For saturation region, the emitter junction and the collector junction are in forward bias. So these are the conditions of the junctions for an BJT or bipolar junction transistor to perform in the preferred upper region. So from this junctions biasing, we can find out the transistor is being operated in which region. And here we can see very well known amplifier circuits for a CE, that means common emitter configuration. That means that transistor has three terminals: the emitter, the base, and the collector. The arrow denotes the emitter and the middle line shows the base, and the another terminal is known as the collector. So if the emitter terminal of the transistor is common, then it is known as the common emitter configuration. And with the help of this common emitter configuration, if we build up a amplifier, then this amplifier is known as CE amplifier or common emitter amplifier. For CE amplifier, the input signal is being applied to the base of the transistor, and VB is the bias voltage. To make a proper transistor is in action, the emitter base junction should be in forward bias and the collector base junction should be in reverse bias. To get this proper operation, we require biasing. This VBB and VCC provide the biasing of this transistor. This capacitor block the DC input from the input source and only allow the AC input to the base. This is the base capacitor which allow only the AC signal to the base, and depending upon this AC signal, the output of the transistor is being produced. So it is the one of the simplest form of the common emitter amplifier which is being used for the amplification purpose. So working of a common emitter amplifier, the base emitter junction is in forward bias by VBE. The collector base junction is in reverse bias by the help of VCC. During the positive half of the cycle, the forward bias is increased, hence the current IB increase. So IC increase and ICRL drop increase. The voltage VCE decrease as the VCE equal to VCC minus ICRC. There is a phase shift of 180 degree in between input and output. We'll discuss all of this one by one in our coming slides. So this is the very first working principle of a common emitter amplifier. So a transistor as an amplifier, when it is C common emitter amplifier, the figure shows the common emitter amplifier for an NPN transistor. The battery VBB is connected with the base in order to make bias forward bias regardless of input AC polarity. Output is taken across the RL. That means it is the output voltage of the transistor. In this figure, we will understand how the transistor works and why there is a phase shift between the input and output. Here we can find it is a input signal to the base. As the base current increases, the effective resistance of the transistor is decreased, and so there is a voltage drop across the output. You can see from this point we can take output, and from this point we are providing the input. If the input signal increases, IB increases, so the collector current IC increases, and that voltage drop across this also increases. So there is a voltage drop across the transistor and we can get a low output. And if the input signal is less, then there is a less base current, and that means there will be less collector current, so the output will increase, so the effective resistance of the transistor will increase. In this way we can find out how the transistor is operated and why there is a phase shift between the input and output. The phase shift is mainly due to the inverse proportion of the effective resistance with the input signal. That means if the input signal increase, the effective resistance of the transistor decrease, and we can find out there is a voltage drop across the transistor at the output. So what happened in this case? If the input signal increase, so the effective resistance of the transistor decrease, and so there is a decrease in the output voltage level. And if the input signal decrease, the IB decrease, so the effective resistance of the transistor increase, and so if the resistance increase, the output voltage also increase. In this way, when there is a positive peak of the input signal, we get a negative peak of the output signal, and in this way we can find out there is a 180-degree phase shift of a transistor between the input signal and the output signal. So we'll move forward. Salient points of common emitter amplifier: the moderately low input resistance, it's in the order of 1 kilo ohm to 2 kilo ohm. Moderately high output resistance in order of 50 kilo ohm. The high current gain, the very high voltage gain, very high power gain, the input and output signal, there is a 180-degree phase shift of the output to input. So these are the, now we can find out the comparison between the common base configuration, common emitter configuration, and common collector configuration of an amplifier. For common base configurations, the current gain is nearly unity. For common emitter configurations, the current gain is pretty much high, and for common collector configuration is also very high. For voltage gain, in case of common base configurations, it is the voltage gain is high. For common emitter configurations, it's very much high, and for common collector configurations, the voltage gain is nearly unity. For common base configurations, the power gain is high. For common emitter configurations, the power gain is also high. For common collector configurations, the power gain is low. For common base configurations, the input impedance is low. For common emitter configurations, the input impedance is high. For common collector configurations, the input impedance is very high. For common base configurations, the output impedance is very high. For common emitter configurations, the output impedance is very high. And for the common collector configurations, the output impedance is also low. For the common base configurations, the phase reversal is not present. For common emitter configuration, phase reversal is present, and for common collector configuration, there is no phase reversal present. The phase reversal is nothing but there is a phase shift in the output between the input with respect to input. If there is a phase shift happen, then there is a phase reversal is present, and if it is not present, there will be no phase reversal is present. So in this way we can make a comparison between the common base, common emitter, and common collector amplifiers, and we can make a comparison between all of these three, and we can find it out from this chart. So why common emitter configuration is commonly used? It is input and output impedance are suitable in many of the applications, and it's offered the current gain, voltage gain, and power gain. So common among these three configurations, common emitter configuration is mostly been used for in case of the amplifier, and it is very famous amplifier among the three comparison: common emitter, common base, and common collector configurations. The common emitter is the major applied amplifier is being used. For that's for today. Thank you.
Thank you for watching. If you have any queries, you can contact to me. The contact number is given. The same number can be used as WhatsApp number. If you have any queries or doubt, you can call me or WhatsApp me to this number. Thank you very much.